What is up, guys? Gunda Math over here, and today we're going to be proving a formula for the distance between a point and a plane. To illustrate this, we'll first start by drawing a little Cartesian diagram, and then drawing an arbitrary line. Okay, and let's call this line ax plus by plus c is equal to 0. Okay, next let's put an arbitrary point x naught, y naught, and a point on the line. Let's call this x comma y. Let's give this just a name a, and let's name this b. And what we wish to find is essentially the shortest distance between this point and the line. Geometrically, it is the perpendicular distance made by the point and a line. So how can we proceed to do this? So as I said, we're going to be doing this using vector projections. And how we do this is we basically join A and B over here, and we basically extend this to show it as a normal vector. So now we know that let's first call it n for now. And we know that the normal vector to any line, ax plus by plus c is equal to 0 is ab. You can try proving this by yourself. So now, how can we get the distance? We see that the distance between these two lines is essentially just a projection. The projection of AB onto n. Yeah, AB onto n. And the magnitude of this, because the projection gives us a vector, we want the magnitude of that vector. So now, let's just write what we need. So all we need is the AB dot n over magnitude of n squared times the normal vector n. And then since we're taking, so this is essentially the formula for the magnitude of the projection of any vector. So simplifying this result a little bit, we can rewrite this as the magnitude of AB dot n over the magnitude of n as follows. Okay, now let's just compute this. So how do we get the vector AB? We know this is equal to vector B minus vector A. So what does this become? This becomes x naught minus x I plus y naught minus yj. Okay, x naught minus yj. And then what is the normal vector? The normal vector is simply ai plus bj. Okay, so now what we do is we do x naught minus xi plus y naught minus yj dot ai plus bj over the magnitude of n. So what is the magnitude? This is still in the magnitude signs, but now we can remove this because the magnitude of n is simply root a squared plus b squared. Okay, so now what we do is now we just distribute the dot product over here. So what is ai dot x naught minus xi? That's just ax naught minus ax. Similarly, bj dot y naught minus yj is by naught minus by, and then over root a squared plus b squared. Okay, so now we're almost done. All we need to do now is we can see that we can simplify negative ax minus by. Because we know that ax plus by is equal to c, we have negative ax minus by is equal to c. So we can rewrite this as ax naught plus by naught plus c. And obviously, if this value is negative, we want to take the absolute value because the distance is always positive over root a squared plus b squared. And this indeed is the formula between any point x naught, y naught, and the line. I hope you enjoyed this video. Make sure to subscribe, and until next time, see you guys.